This was prior to 8080s, huh? By a couple of years.
3 years. 3 years.
3 years. Okay.
3 or 4 years. I had given this system, or what was left of it, to my good friend John Moorhead, M-O-O-R-H-E-A-D. And John collects and saves these kind of things. And lo and behold, John still had everything that I had given him, including the original medical box for the glucose from the hospital where I work. Now this is, of course, the question that Bruce asked, what is that?
An Idealite?
It's actually a prom eraser.
A prom eraser. Oh,
because what it's got is an infrared bulb inside.
It's an infrared bulb?
Or, excuse me, ultraviolet.
Oh, really? So it's like UV?
It's UV, and both lights turn on so that you can tell when you're burning proms or cleaning them.
Oh.
Okay.
Now, how come you had to make them? Did they have commercial stuff like that at the time? Or?
Well, I mean, these were expensive.
I see.
I mean, what did this cost me?
Like $10 maybe.
Okay. And to order one up, and the school didn't have any money. Okay.
Oh, that's always the issue with education.
The school didn't have any money, so if I could build it, make it, invent it, I did. So
that's an early prom eraser.
It's an early prom eraser with a UV light in the bottom and regular light. And at one time I had a kitchen timer that, you know, went off when I had enough hours on it.
Oh, man.
And if you look here, these are 1702 prom chips.
These are the ones that you erased.
And these are the ones that we erased. And what they've got is a little window here, and you're probably erasing them with your bright light.
Right, thanks for warning me.
No, I don't think any of this stuff is anywhere near functional anymore. But starting right here, this is the base front panel, which gave us address and also the data and also some status. And it let us do neat things like sequentially move so we could test things and all that sort of thing. And what this was is this sat underneath a motherboard, which was an extender board on the 4023 terminal, which was a microprocessor-based terminal that Tektronix made. It was a graphics terminal. And in that motherboard, all of these different things plugged in.
Oh.
Okay?
So the motherboard is the part that's not here.
It and the monitor that went with it with a keyboard on it.
I see. Those are the two other components for the system.
But we never had the cover on the monitor, or excuse me, that system. It was actually a prototyping system that had this big motherboard that came out the side so that we could plug all these different things in.
Now this part though,
what that is
familiar to this.
This is exactly what that is. This is the front panel, and if you were to look real closely, you'd find that that has copied almost everything from here. And the reason is that they got this information. There's no question at all that a good portion of the design that went into that came from this specific.
So if you were an archaeologist of the tech, you would say this is definitely a lineage here.
Yes. I'm absolutely certain.
Yeah.
And what happened at that point in time was that the school, by law, had to release information to anybody who asked. And so all we would do is we'd charge them, you know, $5 or $10 for the copying fee, and we would send it off. So we sent details on all of this stuff all over the U.S., in fact, outside of the U.S. in some places, which is kind of fun. So
spread the info,
right.
Information on.
Anyhow, this is just basically a front panel that gives you the ability to see the address, see the data, change the modes, and that sort of thing.
Okay.
Here's, I think, the processor board, and this little gold chip is an 8008, and it's been so heavily loved that it's worn off the 8008. It's the only 18-pin chip.
People have been rubbing it.
Well, it probably was one of the ones we used in our student lab.
I see. So that's the 8008,
right.
Which one of the first microprocessors?
This would be the first microprocessor that actually made it to a computer.
Actually became pragmatically used.
Right. The 4004 was more of a calculator chip or control system.
But it needed a huge amount of support.
Oh yeah.
Chip, right? It wasn't
huge amount of support. This is just the support for that chip, that whole board. Okay. And then what we have here, and it's kind of fun to think about it, what this is this is actually PROM and RAM on the same board. And remember how we were talking earlier about that neat thing I saw at Fry's where you can now boot up your system instantaneously when it's running?
Stick.
Well, that's exactly what we had here.
This is an early, like the precursors to the flash memory USB sticks we have today. Huh?
Yeah, and basically the PROM held the operating system, our BASIC, and our assembler. Yes, and it also carried the firmware that translated the 8008 instructions into the BAL instructions.
Wow. And what about these RAM chips? These are RAM chips.
These are 2102 RAM chips, and what you got here is 2K, is that right?
2K? And 2K RAM chips?
I'm not sure. I don't remember if these are 256. This may be just 256.
For the whole board? Or for each chip?
No, each chip is a 1 by like 256.
Okay.
So with 8, you've got 256 bytes of ROM.
Right, for the whole thing.
For the whole thing. And this is an identical board, which I pirated a lot of the chips off of, I can tell.
Yeah.
So this was its second board that...
Bruce?
No, he's not here.
Bruce?
He's not in the room here. Just, yeah.
That's really odd. I don't know. For now, here.
Okay.
Okay. Well, anyhow.
Can I hand you where he is, Al?
He hasn't been around for about half an hour.
Last time I saw him, he was walking toward the front.
Yeah.
Hello? That is really strange. Okay, thanks.
Yeah. Okay, if I see him, I'll tell him you're looking for him.
Yeah, thank you.
Next time I'll bring my walkie-talkies.
Are you okay?
Yeah, oh yeah, great.
So anyhow, what's really innovative about this is it allowed instant power on. You had your operating system, you had your firmware, you had everything that you needed, including a basic interpreter sitting right there.
It just would boot up.
It would boot up and it would run.
Wow.
Okay. And Tektronix was really nice about taking care of me with this particular set of hardware because they also let me use their SCSI interface, which was integral to their monitor terminal system that plugged in. And so what we ended up with was a SCSI that we could attach to a hard drive, and we did. We had a 3 fixed, 2 removable system, and we put that with this, and it actually gave us, you know, a 5 meg storage capability. Wow. We only got to use 2 of that because it was a shared drive, believe it or not. We'd wheel it between computers and plug it in because it was so expensive. Isn't that crazy? Now, just to get a kick out of some of these things, now this is a 1970, I think this may be a 73 because they upgraded once for me. And what it is a serial and a modem capability. And believe it or not, you got 150 baud going all the way up to 9600 baud. And the 9600 baud
was unheard of at the time.
wasn't even supported by our host. Yeah. We couldn't do that. But again, that's 1971 that we were in 9600 baud.
Yeah, I mean,
okay,
geez.
and when did PCs break out of that?
Not until the 90s. I mean...
Yeah, late 90s.
Yeah.
Yeah.
I mean, that's remarkable.
The U.S. robotics modem was what?
Well, there was...
The highest they got to was like 4,800 or something like that, 52?
And then there was the, 9600 came, and then
Well,
14.4, I think, was after that.
Yeah, and the highest was 48K,
yeah,
roughly.
Yeah, 48, and then the 56K.
56,
well,
okay.
Yeah, and that was that.
But anyhow, that's 72 at 96, which I think you might get a kick out of. And then let's just take a little tour on each one of these. This is a data communication card.
Yeah.
And what it allowed us to do was to talk to things like our AdMaster paper tape reader, which was a real high-speed servo-driven unit that just poured through the paper tape. And believe it or not, originally when we got the thing set up to talk to it, we had to use the teletype, just like that one over there.
I guess these were the standards, and then those
Our mainframe would talk to that. We would get that, translate the card deck onto paper tape, and then the paper tape. So what we did was we just looked at the data communications card, and again, it had the ports so that you could go off and talk to various things, which is kind of neat. This one here is another basic data communications, but this one here will actually let you talk to, I think this was an early SCSI. but 1972, which is kind of an interesting,
Yeah, early SCSI. Yeah.
early SCSI
SCSI
was still getting done. Now this one here talks to the teletype.
so that was the teletype interface.
This was the teletype.
33.
Yeah, this is the teletype interface,
I'm sorry.
Yeah.
which is
You
kind
see
of
this? Look at this one, the 8085 version.
Whoa,
This is the prototyping kit that I learned machine language on.
did you really? Oh, that's neat. Okay, this is a tape player recorder.
Ah,
Okay, and this is a 1971,
perfect.
way before Don Tarbell or any of the PC type guys even heard of systems. This was a working unit that worked with like a Sony high quality recorder, and you could both play and save data on an audio tape with this.
My dad's construction.
Playing something on a tape? I mean,
On an audio tape, yeah. And it used an audio tape deck,
Oh,
and all you could actually control the tape deck if it had the
controller capability.
solenoid electric. And it actually is one of the very first, to my knowledge,
Control.
audio
Audio.
tape interface for
What did
data.
it have to do exactly for audio? I mean, it wasn't storing the actually audio files, right? It was
Storing screeches.
screeches.
Yeah, high screech was a 1 and a blank space was a 0.
Okay, so
I'm serious. That's actually what the tone was. If you listen to it on a headset, you just heard this terrible loud screech.
and that was one state, and
That's ones and zeros.
wow, that's what it did. It just
That's-
put ones and zeros on the tapes.
Yeah, but
Right.
they were screeches. They were either there was a sound or there was no sound.
See.
And it would,
Zero literally went nothing.
yeah, and what we did was we'd turn the volume off on the recorder,
Yeah.
and if you wanted to make sure that you had, a tape that was data instead of a blank one or whatever, you turn the volume up a little bit, and then it would either screech at you saying, hey, there's something here, or it would be just blank tape. So anyhow, 1971, we had basically a working interface that worked with regular audio tape drives, which is kind of fun. This here is probably one of the most important additions that Tektronix added. And again, now Tektronix took pity on me because I had an 8008 that we built the hard way and it didn't work real well. And I moaned at them because I couldn't figure out what the heck was going on. My analog scopes were too slow to track the information on the microprocessor. So what this is this is an extender board that's also a full diagnostic board. And what you had is LEDs with gates, and if the signal went, you could set it so that the LED would stay on or it just flash or whatever. And things were going on so fast that it'd be nice to single step your machine through and then watch what the LEDs did so that you could see whether the right data and addresses and so forth were being used.
Yeah, wasn't that like part of what the front
In
panels
fact,
of these machines are?
If you were to look right here, and this poor switch has been a little bit down because it got more wear and tear than any other switch on the front panel. It was the single step switch. And you'd go one step at a time and validate whether or not it worked or not.
Wow.
So anyhow, what this motherboard did was, this is a let's see what year they put this one out. This is a 1972 board, and it basically gave us the ability to do the diagnosis needed to make the digital systems actually work and behave, which was pretty interesting. It was a lot of fun.
Yes. These guys, again, knew about that technology too. They applied some of these ideas from an archaeological point of view.
What happened was I released all the circuit diagrams and so forth for all of this. And when I helped Intel with some of their other work, what they did is they responded by giving us the 8080 processors. And so what I did was I upgraded and I made my own front panel that was similar to this, and I made a motherboard, and we only had some of these real cheap connectors, but they were hundreds. So we used those, and eventually that became the S100 bus. But I made a processor board and I made a front panel board rather than having it as integral, which was kind of built into the machine and soldered onto the motherboard like Altair did. I made it a plug-in board that sat at the front of the motherboard, so you could change that around for different types of diagnostic functions. And it was an easier way to see what was going on. And then, if you notice, the M side there has a total of 5 different banks of lights, which can tell you what kind of functions you're doing on an I/O, and then you've got both data and your address, and then you also have your function keys here where you're in single step and so forth. This panel is something that I engineered, and the guys who started this company got that engineering from me and
Through this project here.
through this project here, which was kind of fun.
Did you know the MSI guys? They were across the bay, weren't they?
I didn't know them super well, but they, in theory, I was part of the company because I did so much early work with them.
Yeah.
But what I mostly did was free consulting until I got grumpy and said that was enough for this day. Does that make sense?
Yeah.
That's actually serial number 4 MSI,
Wow.
which is kind of fun.
That's one of yours too.
That's one I brought in for Bruce. That's what started me on getting into this 8008. But what that is that's probably the best hot rod that unit ever became. It's got the upgraded motherboards, the upgraded power supply, the upgraded front panel. It has the
what we call fully loaded. Huh?
Yeah, it has the newer version, high capacity floppy drives, and just all kinds of other things, you know, that were innovations. The single card memory, which had all 64K, and then had a separate bank of ROM where you could switch from ROM to RAM and do all kinds of fun things. That was a pretty heavy-duty machine for its time.
What was this model? Was this an?
This was something that MSI actually came out with later than this.
Yeah.
And they did this primarily for a word processing box that didn't confuse people. You got 2 buttons. That makes sense. Okay.
Yeah, no, the guy who gave us that designed WordStar. So,
I've heard that.
Yeah.
I'm not sure I believe that, but I heard that.
Well, he runs on this machine.
Oh, I agree. I don't know that he designed WordStar, though.
Oh, I see.
And the reason that I say that is that I happen to know that Mike Latta, who was a very, very sharp student at Cal State University, wrote a package which was called VEdit. And VEdit was what we use for documenting our medical system. And VEdit was added to become Electric Pencil. Okay? VEdit was widespread. We gave it to anybody who wanted it.
Yeah, that's what we mentioned earlier, is that Electric Pencil had its origins.
Well, VEdit got upgraded over time, and we added, in fact, I personally wrote the daisy wheel routines so I could do proportional print. Okay? I looked at WordStar. I had a disassembler so I could take it apart and see exactly what the code was. A lot of that code came from many other people. That wasn't
So it was like
fresh. It
cut
was
and splice together.
Yeah, and almost everybody did that, and that's not a bad thing. But
That's a normal thing. But
a lot of guys today are going, well, I did that all by myself. And the truth of the matter is I pirated designs here from Wang, from IBM, from Data General, from Varian Data Systems, you know, in building this box right here.
Yeah, but then and that piracy allowed all this to exist.
Exactly.
And it wasn't really piracy in those days because software really was
got
in its
shared.
infancy, right? It was a language just forming.
Yeah, it
So
was.
everyone was borrowing words because they were creating some kind of common language.
Sure, and the motif was, like I explained earlier, IBM, one of their big benefits was that they had this huge pool of software that they organized and their software engineers made available for their customers. Well, every computer firm, including most of the ones in here, did exactly the same thing. They went out and they gathered different pieces of software, modified it to work on their particular hardware, and they would give it away to their customer base.
So it wasn't
Yeah.
something you charged money for. So it was,
Yeah, so
yeah.
if you look at WordStar, it actually has its origins back in a program called WordMaster. And WordMaster was what VEdit was from early on, and VEdit, frankly, was from the Wang word processing package that was being used by the state of California for a whole bunch of typists to.
Now, was it easy to get this software from various sources?
Well,
or?
I was in a neat position because at the university, everybody brought me their toys.
I see. Yeah, so you were like a clearinghouse.
I was a clearinghouse for this software. In fact, I spent more time building paper tapes than I did working.
Wow.
In fact, I got in trouble over that. My boss got mad about how much time we were spending. We almost needed a full-time clerk to just take care of the paper tapes and stuff we were launching. Huh. But, well, just like the BAL, I mean, the BAL itself didn't run. Because what we did was we eventually coded it down to running in the real-life code that the microprocessor worked. Does that make sense? Because it was too slow to run it in BAL with an emulator.
Yeah.
So we compiled down to BAL, and then we cross-compiled from BAL down to 8008 or 8080 code. And that gave us all these different toys like DOS. I gave Intel our version of DOS. I know that Gary Kildall interviewed with them to maybe make that a better system and to put software and so forth on it. And he chose not to go to work for him, but not long after, I saw CPM appear, and 60 to 70% of CPM was the DOS that we handed to Intel. And it, you know, I don't consider it stealing. It wasn't stealing then. It was freely shared.
That was part of the culture.
Right. I was a member of the University of California at San Diego Microcomputers group. I've never been to that campus. But I became an honorary member because I gave them a DOS tape or a BASIC or something like that. And so one of the professors that we had was trained there at San Diego. So anyhow, it wasn't the same world then. It was all hardware.
I can see it has its origins probably in the open source movement today.
Yeah.
People saw the value of it.
Oh, it was incredible.
And so it was a natural to continue that line of thinking.
Yeah.
Yeah, very cool. Very
but anyhow, it's funny because, you know, I hear, and in fact I read, if you go out on Wikipedia and you start reading history and so forth, gosh, it reads like, you know, so-and-so built everything from scratch in 2 days. And the world didn't work that way back then.
It was much more of a collaborative process. It
was a very collaborative process, with the clearinghouse being the different universities.
Yeah.
We were all on the internet. We were all trading emails way before the internet was released to the public.
Wow, so that really helped spawn this whole...
Yeah, and a lot of that information traveled via internet, believe it or not, over teletype, paper tapes.
Yeah.
And I had a version of the Waterloo Basic, which was a paper tape about 6 inches in diameter. And I never successfully was able to send that to anybody. The equipment was so unreliable that we could not physically send something that long with it airing out and failing and have to start over. It's terrible. But anyhow, it was us against the technology. It wasn't, you know, these little fiefdoms and stuff. Like, the main calc program, that basically was something that was written for the government. It was a big spreadsheet. It worked on the mainframe host systems, spread all over the US. And Apple came out, and lo and behold, here we got VisiCalc. And if you look at the main calc book there, you're going to find that it's got most of the features of VisiCalc, plus more, that were all written and being used all over the US on mainframes.
Wow.
Okay.
It's another early origin story.
There's just a lot of stuff, which was kind of fun.
Yeah, that's hilarious.
Anyhow, I think that's kind of the 9 yards here.
That's great.
This is the first box that I built. And
now, when you say you, do you have a team of students working with you?
No,
or did you have...
no. I sat in a little tiny lab by myself.
We're talking all this collaboration stuff, but you're talking by yourself here. Right?
Well, no, I was talking with people all over the U.S.
So you're talking with people, getting the information.
Right.
But when it came to building the box...
When it came to building the box, I had like 2 graduate students that I'd go bug with questions when I got into trouble.
Okay.
And then I had 2 electrical engineer technicians that would help me with putting things together.
Yeah.
And like this box here, turned out it was a standard box that you could buy. And I designed the front panel. This is my very first front panel. And it's so interesting because if you look at this front panel, it's identical to the Altair.
Wow.
Okay, and this is the box that we actually gave to Intel, and they put their little logo on the thing.
This was like 2 years before, the September '73?
Yeah, it'd be right about then. Wow. And this book here, a lot of the material in it is from stuff that we learned by the hard way of making mistakes.
Wow.
Which is kind of fun.
Wow. So who published that? Intel?
This is Intel. Yeah.
Wow.
They made it into a microcomputer set with a prototyping area and then extender boards, and they basically copied the RAM boards and CPU board and front panel that we had designed there at Sac State,
wow.
which is kind of fun. And we didn't design it for microcomputers.
Wow.
You know, we designed this for a medical system, and it was medical. We weren't playing with hobbyists. We weren't, you know, working in any kind of groups like that. We were strictly trying to put together a professional system.
Gotcha. Did you visit Intel?
Yeah, I made quite a few trips back and forth, and they were really generous in terms of, I'd always come back with a little baggie full of memory chips.
What was the culture like then? Was it much smaller, informal than it is today?
Yes, very much so. In fact, I don't think I talked to anybody senior. I went directly and worked with the engineering team.
You could just walk in the building and do that?
Well, they usually met me.
Yeah.
It soon got card only, you know. But
back then it was open.
Yeah, but it was rough because I didn't have a cell phone back then. So, you know, you're sitting there pounding on the door waiting for somebody to let you come in, which is kind of fun. But yeah, that was basically it. It was a fun little ride, and it was a lot of hard work. We gave up on this technology because it just didn't have enough storage room to put the programs in that we wanted for the medical system. So when the 8080 came out, and the 8080 had a much bigger address range, you know, it would handle a full 64K. And so,
just a natural
evolution. And that machine right there actually was used in the medical world until 1985 doing processing.
What did you use it for, like billing?
No, this one maintained a nutritional history, a personal history, a medical questionnaire, a physical physiology measurement where they measured all the different lab work and so forth, and then it compared the lab work over time to see if anything was going out, like your cholesterol starting to climb or your blood pressure is changing in a bad way or a good way. And it gave doctors a way to see when changes were happening much faster than if they normally a doctor memorizes the ranges, and they don't show a red flag until somebody pops out of the range. What this did was it graphically showed progression in a negative direction, so that maybe you can say cut your cholesterol because you're really starting to climb. So that's the one that we actually took the results from to the FDA, and we got little plaques from them and attaboys, and that got shown off at the AMA, and it also got shown off at California Medical Association, and then American Medical Preventive Society.
You know, reminds me, did you know, a magazine at the time called Physicians Microcomputer Report?
I remember the magazine. I don't know any of the
late
people.
70s.
Yeah, that was well after this thing was retired.
This was like mid-70s?
This essentially was retired from a development machine. It actually went to a key data station where they would enter the patient information. It went to that in 1976.
Oh, okay.
So it was 76 to about 85. It was used in production by production people. Does that make sense? Doing nutritional analyses and that sort.
In the labs.
In a lab. There was a single lab. People would mail in their forms. We'd process them and ship them back their forms plus the output.
Nice.
And
was that here in the Bay Area?
no, that was actually all done in Sacramento.
Oh, that's when you were doing this, the work with the government then.
Right.
Wow, very cool.
So,
well, thank you. Appreciate it.